Hey, good people. This is Arthur Morris. I hope that all is going well with you today. In this video, we are going to look at partial fraction decomposition of rational expressions with linear factors in our denominator, some of which are repeated. So repeated linear factors in our denominator. So to set these up, we use this form here, the form of the partial fraction decomposition. If we have p of x over ax plus b to the nth power, then we have a sub 1 over ax plus b plus a sub 2 over ax plus b to the second, all the way up to ax plus b to the nth. So we have to include one fraction with the constant numerator for each power of ax plus b. Okay, so with this one we want to write the partial fraction decomposition of negative 8x plus 2 over x plus 4 squared. So I'm going to set up the other side of my equation to be, since I have squared here, a over x plus 4 to the first plus b over x plus 4 to the second. So we have this repeated linear factor, and this is how we set up the partial fraction decomposition in order to solve it. So now we need to find the values of a and b, and from here we use the same steps to find a and b. We want to multiply both sides by the least common denominator, which should be your denominator on your left-hand side of the equation. So x plus 4 squared Okay, so when I multiply the left-hand side of the equation by x plus 4 squared, I'm left with negative 8 times x plus 2. On the right-hand side, remember we have to use the distributive property, so I'm multiplying x plus 4 squared times each one of the fractions. In the first fraction, in my denominator of the first fraction, I have x plus 4 to the first. So one of those x plus 4s will cancel out, and that will leave me with a times x plus 4 to the first. Now when I multiply the x plus 4 to the second times the second fraction, both of my denominator has x plus 4 squared, and I'm multiplying by x plus 4 squared. So those would cancel out and just leave me with b. All right, so here we want to clear our parentheses. And we can group. We don't have to move anything. The x terms with the x terms. We only have a times x and then the regular constants. Now we can create our linear system. So the ax goes with the negative 8x. So a equals negative 8. And then the 4a plus b goes with the constant 2. So here's our system of equations. We have equation 1 and equation 2 there. Well, since I only have a equals negative 8, that's great. I know the value of a. I just need to find the value of b for this particular problem. So a equals negative 8, that's great. Let's find the value of b using equations 1 and 2. So since 4a plus b equals 2, then 4 times negative 8 plus b equals 2 by substitution. add 32 to each side. So the value of b is 34. Now I can take the a and b, go back up, and replace those variables. So a is negative 8. And the negative can be out to the side of the fraction, or it can be in the numerator with the 8. And b is 34. And that is our partial fraction decomposition. Okay, let's try another one. I promise you this one will be more fun. Alright, so we want to write the partial fraction decomposition. Again, we need to look at our denominator and see what type of denominator we have. We have linear factors. One of our linear factors is a repeated linear factor, the x minus 2 to the second. And then the other linear factor is not repeated. So when we set this up, I'm going to look at my x minus 2 to the second first and write a over x minus 2 to the first plus b over x minus 2 to the second. And then my other factor is x plus 1, so plus c over x plus 1. All right, so now this is set up to go ahead and start solving. So let's multiply both sides by the least common denominator, which again should be the same as my denominator on the left-hand side of the equal sign, my original expression. So on the left-hand side, the denominator cancels with the x minus 2 squared times x plus 1. So I'm left with x squared. On the right-hand side, we have to multiply each one of the fractions times x minus 2 squared times x plus 1. So when I multiply the first fraction by that outside there, one of the x minus 2's will cancel. Everything else I need. So I need another x minus 2, so a times x minus 2, because only one of them cancel, times x plus 1. And then I'm going to multiply the second fraction by the x minus 2 to the second times x plus 1. So my denominator in the second fraction, x minus 2 to the second, cancels with the x minus 2 to the second that I'm multiplying by, and I'm just left with b times x plus 1. And then the third fraction, the x plus 1's would cancel, so I would have c times x minus 2 squared. Alright, so I need to use my distributive property or FOIL, however you want to multiply that out. So that will give us x squared minus x minus 2. And then using our binomial, perfect square binomial rule, or the difference of a binomial squared, which would give us the first term squared minus 2 times the terms minus the last term squared, or plus the last term squared. So x squared minus 4x plus 4. Or you can go out to the side and multiply x minus 2 times x minus 2 using FOIL or distributive property. Okay, so I'm going to clear my parentheses. And then I'm going to rewrite that left-hand side in descending order and the right-hand side as well. I have a couple of missing terms that I'm going to add in on the right-hand side. So I start off with x squared. So I'm going to add in a 0x and a 0 for the constant. All right. On the right-hand side, I have ax squared and cx squared. Plus, I have negative ax plus bx minus 4cx. 4 times c times x. And then I have plus negative 2a plus b plus 4c. Okay, so as you can see, we are going to have three equations for this system. So we have the ax squared plus the cx squared, and on my left-hand side, we have 1x squared. So a plus c equals 1 would be my first equation. And then my second equation, I have negative ax plus bx minus 4c, so negative a plus b minus 4 times c would equal, matching up with the middle term, 0. So I had 0x on the left-hand side. And then equation 3, negative 2 times a plus b plus 4 times c. Again, that would equal 0 as well. Alrighty, now my job is to solve this system that I created for A, B, and C. So I'm going to eliminate my A's. I'll eliminate my A's in equations 1 and 2, and then in equations 1 and 3, and then combine my new equations. So I'm going to flip over to another screen. If you need to pause here and finish jotting this down, then you can. All right, so equation 1 was a plus c, and equation 2 was negative a. Let's just write those down. Uh, equation 1, a plus c equals 1. Equation 2, negative a plus b minus 4c equals 0. And then equation 3. All right, so I'm going to start off by combining or eliminating a in equations 1 and 2. And as you can see, they're already set up to be eliminated because I have positive 1a in equation 1 and negative 1a in equation 2. So I don't have to change anything. And I'll leave a blank there for the b variable. All right, so the a's cancel. I end up with b minus 4 times c equals 1. Or minus, I'm sorry about that, that's b minus 3 times c equals 1. So that's my new equation. We'll call it equation 4. Now let's combine equations 1 and 3 and eliminate a as well. So equation 1 has the coefficient of 1 on the a. Equation 3 has the coefficient of negative 2, so the least common multiple would be 2. So I'm going to multiply equation 1 by 2. And that will give me a positive 2a to eliminate with my negative 2a. So 2 times a, 2 times c, and 2 times 1. and then equation 3. So the A's cancel. We end up with B plus 6C equals 2. All right, so now we use equations 4 and 5 to find the values of B and C. So if I want to eliminate B, I'm going to multiply equation 1 by negative 1 because both of them have the coefficient of 1, but I need one of them to be negative 1. So I'm multiplying equation 4 by negative 1. Equation 5, I'm leaving it like it is. Okay, so we end up with 9C equals 1. Therefore, C equals 1/9. All right, so now I know the value of C is 1 over 9. Let's find the value of B. So using equation 4, and I'm going to circle this so I'll know where it is. Using equation 4, I'm going to find the value of B. And it doesn't matter, you could use 4 or 5 to find the value of B. So I have 3 times C, so that would be 3 times 1/9 equals 1. Negative 3 times 1/9, 3 and a 9 would simplify, so that gives me minus 1/3. And I'll go ahead and change this 1 into thirds as well, which would be 3/3. Add 1/3 to both sides. So B is equal to 4/3. We also need the value of A. So if you go back to our equation 1, original equation 1 up here, it says A plus C equals 1. So A plus 1/9 equals 1. Or A plus 1/9 equals 9/9, getting a common denominator there. Subtract 1/9 from both sides. All right, we should be able to write our answer now. So we had C equals 1/9, B equals 4/3, and A equals 8/9. So remember we had A over x minus 2 plus B over x minus 2 squared plus C over x plus 1. So A is 8 over 9, so 8 in my numerator, 9 in my denominator, times x minus 2. B is 4 over 3. And C is 1 over 9. Alrighty, I know that was a lengthy problem, but that's it for this video. I hope you found it to be helpful, and I will see you on the next one. Thank you.